Hello friends, myself Shubham and you're most welcome in Shubham Technical. Please like and subscribe.
Tool holders are used to adapt tools of different shapes and sizes accurately and securely to a milling machine spindle. The shanks are shaped to fit various standard machine tapers, including R8, NT40, CAT40, and BT40. Pull studs are threaded onto the backs of tool holders designed for CNC machines. Several different types are available. Face mill holders are available in various sizes and consist of an arbor, 2 drive keys, and a retaining bolt. A solid end mill holder consists of a precision bored hole and a set screw. The set screw clamps down on the weld-on flat of the end mill, providing a very secure grip with a slight loss in concentricity. An ER collet chuck consists of a collet nut, a collet, and a tapered socket. ER collets have very wide gripping ranges, allowing the chucks to hold many different sizes and types of tools. Thanks to their high concentricity and versatility, they are also frequently used in live tooled lathes. Milling chucks are very precise tool holders with high gripping power. They are ideal for holding larger tools as well as high-speed applications in mold making. Drill chucks are very convenient for holding drills as well as other plunge cutting tools. A keyless drill chuck allows rapid manual swapping of drills, while a spanner wrench can be used for extra gripping power when necessary. Specialty holders are also available, such as this modular unit used to hold boring heads. All tool holders featured in this video were manufactured by Glacern Machine Tools. Face milling is the process of machining a flat surface on a workpiece. A cutter is mounted to a face mill holder, which consists of an arbor, 2 drive keys, and a retaining bolt. Carbide inserts are secured to the cutter with screws. A face mill with positive axial rake reduces cutting forces and vibration. The milling head should be positioned close to the workpiece to minimize quill extension and maximize rigidity. Locking the gibs on the Y and Z axes will further improve rigidity. Steel and brass materials can be cut dry, while aluminum, stainless steel, and titanium should be cut with an appropriate lubricant or coolant. The FM45 indexable face mill shown here is manufactured by Glacier Machine Tools and uses square inserts tilted at 45 degrees. Each insert has 4 cutting edges and can be rotated 90 degrees to expose a fresh cutting edge. WD-40 serves as an excellent lubricant for cutting aluminum on a conventional machine, preventing soft aluminum chips from welding to the cutting edges. However, proper ventilation is required due to the smoke it creates. Aluminum is being faced without lubrication in this demonstration, but coolant is recommended in a production environment. A finishing pass is performed with the material being fed at the same rate, but with the cutter spinning at a higher speed at a shallower depth of cut. Rectangular inserts, such as those used on this FM90 face mill, have 2 cutting edges instead of 4, but are capable of milling shoulders and slots. "90-degree flat end mills are used for profiling, slotting, pocketing, and boring operations. A roughing end mill has serrated cutting edges for creating fine chips and reducing vibration. These end mills create a rough texture on the workpiece. A standard end mill can be used for roughing as well as finishing. This extra long high-speed steel end mill has 4 spiral flutes. A similar end mill with 2 flutes is also available. Unlike a roughing end mill, a standard end mill produces full-length chips and a smooth surface finish. Coated carbide end mills are more rigid and heat-resistant than high-speed steel cutters. Feeding the workpiece against the cutter rotation is known as conventional milling. This is recommended on manual machines. Feeding the workpiece in the same direction as the cutter rotation is known as climb milling. This can backdrive the lead screws and produce chatter marks in manual machines. As cutting speed increases, chips change from silver to straw-colored to dark blue. Solid carbide end mills coated with aluminum titanium nitride are recommended for cutting steel without coolant in CNC machines. In conjunction with climb milling, as demonstrated in this profiling operation, the heat-resistant coating can improve cutter life. Cutting a pocket begins by ramping the end mill into the workpiece. Ramping is recommended over plunging due to the improved evacuation of chips. Chip removal is also facilitated with the use of compressed air. Helical boring can be used to machine large holes without the use of drills or boring heads. Aluminum-specific end mills have shallow helix angles for aggressive cutting and fewer flutes for increased chip clearance. These end mills are coated with zirconium nitride, a hard coating with a very low coefficient of friction. As usual, coolant is recommended for cutting aluminum. Indexable cutters, such as the Glacier EM90 end mill, use replaceable carbide inserts. They typically require more horsepower than solid carbide end mills, but can be more economical due to the low cost of inserts and can cut deeper pockets due to the increased rigidity of the larger diameter shank. Drills are the most commonly used tools for creating holes. Short spotting drills are used to create shallow, conical holes, preventing longer drills from wandering off center. Frequent retracting, known as peck drilling, helps clear chips. Screw machine drills are much shorter and can drill straight, accurate holes without spotting. Programming a CNC machine to drill holes is simplified with the use of canned cycles. The table and spindle initially traverse to the starting position of the first hole. The G81 command, followed by various parameters, initiates the canned cycle. G81 is a modal command, meaning it stays active until another command cancels it. Drilling additional holes only requires specifying new coordinates. Drilling into an angled surface requires spot facing using a center cutting end mill. After spot facing, a standard drill can be used. Chucking reamers are used to enlarge pre-drilled holes to very precise diameters. Slow speeds as well as coolant or lubricant should be used. Power tapping is a fast way to tap holes on a conventional machine equipped with a quill and a 3-phase instant reversing motor. Synchronized rigid tapping on a CNC machine is accomplished using the G84 canned cycle. Helical boring with an end mill is an economical way of creating larger holes. Deeper holes can be made using a boring head. The adjustable twin cutter unit shown here is used to enlarge pre-drilled holes. A finish boring head holds a single adjustable cutting edge for the highest precision and the smoothest finish.